Let us do this question. In this, he says AB is an L-shaped obstacle fixed on a horizontal smooth table. So it is fixed on a horizontal smooth table. That means it will look something like this. It will look something like this. So it has been given a little bit cross in this thing. So we will take this as straight. So ball would be coming like this. It will be coming like this and hitting in this way. Then it will deflect and hit here. Then it will go in this way. So this is what will happen to this ball. This is how the entire scenario will look like. Okay. So this L-shaped table or L-shaped obstacle is immovable. So if it is immovable, it means it will not have any velocity. So we will understand first what is meant by coefficient of restitution. Coefficient of restitution E is equals to velocity of separation by velocity of approach. Velocity of approach. That is our coefficient of restitution. Velocity of separation, if I take this as some v1 and this is some velocity, this velocity v or u1, initial velocity u1, velocity of this is v. So velocity of separation after this, the velocity of this obstacle is again zero. Initially also it is zero. After the ball hits also it is zero. So the velocity of separation when I write, that is velocity of ball minus velocity of this obstacle divided by separation. Velocity of the ball minus initial velocity of the obstacle. So final velocity of the ball minus velocity of obstacle divided by initial velocity of the ball and minus initial velocity of the obstacle. This and this is anyhow zero. So E is equals to, it will be simply the ratio of final velocity of the ball divided by initial velocity of the ball. Final velocity of the ball is equals to E into initial velocity of the ball. This is what you should understand. In this, the key concept is this: coefficient of restitution value is equals to velocity of separation by velocity of approach. Velocity of ball minus obstacle is anyhow zero. Initial velocity of it is also zero. So both will be zero. So velocity of ball divided by initial velocity of ball is equals to the coefficient of restitution. I hope you understood this. From now onwards, we'll be directly writing this part at everything. Okay. Sure. So now what we'll write is, we'll try to write. So we now understood that concept. Now let us write this velocity. This velocity is in, like it is coming like this. It can be broken into two components. It can be broken into two components. One component is in horizontal direction and one component is in vertical direction. This is how this ball is approaching the obstacle on the A side. Okay. So let us take this as V1 and let us assume this as V2. With which velocity it is going to hit the obstacle is, with V1 it is going to hit the obstacle. Understood? So V1 is the initial velocity before collision, because collision will happen with this velocity only. Collision will not happen with this velocity because V2 is parallel to A. So collision will happen with only V1 velocity. I hope you understood this. So after collision, now what will happen? This V1 will convert into, let us take V3. Now the ball is moving in this way. So it is going in this way. That is the final velocity after collision. And V2 will be just like that. There is no thing. Okay, this is V2. Okay. Now we should get the relation between V3 and V1. Coefficient of restitution is equals to velocity of separation divided by velocity of approach. So velocity of V3 is the velocity of separation is equals to E into V1. I hope you understood this. So V3 is equals to E into V1. So this is my E into V1. Fine. I hope you understood this. Now what will happen? Now at B position, with which velocity it is going to hit? It is going to hit the floor with V2 velocity. Now here it is hitting like this. Now it will be coming up in this way. It will be coming up in this way. V3 will be as it is because V3 is parallel to B obstacle. So V3 will not change. V2 will convert into how much? Just same again, E is equals to velocity of separation divided by velocity of approach. This is my velocity of separation. Let us take it as V4. V4 upon V2 is equals to my E. V4 is equals to E into V2. That means V4 is equals to, this is E into V2. This is E into V2. And V3 is how much? That is E into V1. I hope you understood this. This is the final velocity of the ball, EV2 and EV1. Previously, when V1 and V2 were there, the velocity was taken as V. Now, when EV2 and EV1 are there, their resultant would be E into V. Okay, because EV1 is present in horizontal direction, EV2 is present in vertical direction. The resultant would be E into V. So the final velocity of the ball is E into V. Now we have to understand the sign. If I take this sign as positive, V as positive, I take this sign as positive, this would be in negative direction because it would be opposite to it. So what would be the final velocity? Final velocity would be minus EV. This is my answer. If you have any doubt, you can comment below. Thank you.